Hello, dear friends. Welcome back to my channel Tips and Tricks by AMB. In this video, I am with another new chapter, which is one of the important processes not only in the pharmaceutical industry but also in our daily activities, and that is drying. But before moving further, do one thing. What? You know it well. If you didn't subscribe my channel yet, please subscribe it, like this video and share it to your dear ones. Don't forget to click on bell icon to get notifications of all my new videos. The learning outcomes of this session are: the learner will be able to define drying, describe applications of drying, classify dryers, describe construction working advantages and disadvantages of fluidized bed dryer. But before moving further, I want to ask you a question, and that is, what do you think drying is? Pause the video, think about it, and write down it in your notebook. Then play the video again. So let's discuss what is drying. Drying is an important operation in the pharmaceutical industry. Proper drying can prevent deterioration of the product and also improves its solubility. In medicinal preparations, drying is usually the final stage of operation used to remove liquid or moisture from it. Drying is defined as the final removal, that is removal of traces or small amounts of liquid from solids by vaporization with the help of heat. In drying, more emphasis is given to solids. Thus, drying involves the removal of water at temperatures below its boiling point, whereas evaporation is the removal of water by boiling. The equipment used for drying is called as dryer. In drying, water is removed by circulating air or some other gas over the material to be dried. In some processes, the carrier gas is not used. Some methods of drying are non-thermal in nature. Example is desiccation. Now, before moving further, there is a reflection spot for you. Pause the video and think why drying is necessary in case of farm products and in home too. Think and enlist the reasons behind drying. Then relate these reasons with pharmaceutical industry. So let's discuss why drying is necessary in pharmaceutical industries. In pharmaceutical industries, drying process is required to convert a wet filter cake into a free-flowing powder. Easily grind vegetable drugs, improve storage and rate of extraction of vegetable drugs, and convert wet granules to free flowing dry solid granules, etc. Now let's discuss about applications of drying. First application of drying is: it is one of the important processes used in the manufacturing of granules, which can be dispensed in bulk or can be used in the processing of tablets or capsules. Next is, drying reduces the bulk or weight of the material and is hence useful to reduce the cost of transportation and storage. Another application is, if moisture is present in crude drugs, it leads to mold growth in it. Drying removes moisture from the crude drugs and preserve them. Also, presence of moisture in crude drugs makes them difficult for the size reduction process. Drying by removing moisture from crude drugs increases the rate of size reduction. Last application is drying is also useful for preparation of various pharmaceutical materials like dried aluminum hydroxide, lactose, and preparation of solid extracts, etc. Now we will move further to discuss about drying equipments. The equipment used for the drying process is called as dryer. Dryer can be classified by different ways as follows. First classification is depending upon the drying processes used. So, as per the drying processes used, dryers are classified as batch dryers and continuous dryers. Batch dryers are the dryers in which the material is inserted and drying proceeds for a given period of time. After drying, material is removed. Thus, it is a batch process. Example of batch dryers are tray dryer, vacuum dryer, freeze dryer, and fluidized bed dryer. Continuous dryers are the dryers in which the material is continuously added to the dryer from one side and dried material is continuously removed from the other side or outlet. Examples of continuous dryers are tunnel dryer, rotary dryer. Dryers can also be classified depending upon the source of heat as hot air dryers, hot surface dryers, and freeze dryers. In hot air dryers, heated air is used as a source of heat and vapors formed are removed by the flowing of this hot air. Examples of hot air dryers are tray dryer, rotary dryers, fluidized bed dryers, spray dryers, tunnel dryers. In hot surface dryers, as name indicate, the heating surface provides heat to the drying material by conduction mechanism. These dryers have advantages like no need to preheat the air before starting the drying process. And drying can be carried out in absence of oxygen to prevent oxidation of material. Examples of hot surface dryers are drum dryers and vacuum dryers. Freeze dryer is used when the material is heat sensitive. In this chapter, we are going to discuss only two dryers with fluidized bed dryer and freeze dryer. Let's discuss about fluidized bed dryer. First, we will see what is fluidization. Fluidization is a process where a granular material is converted from a static solid like state to a dynamic fluid like state. This process occurs when a fluid, that is liquid or gas, is passed up through the granular material. Before moving further, think about how solids behaves like fluid, how fluidization can be achieved. Pause the video, think and write your answer in your notebook. Then play the video. Now let's see how solids behave like fluid. That is theory behind fluidization. To understand fluidization, you can imagine the example of twister as shown in the video. In video, you can see that various solid particles are moving along with air and behave like air. This is nothing but fluidization. It is achieved by passing a fluid, that is gas or liquid, through granular solid material. So let's understand theory behind fluidization. When a gas flow is introduced through the bottom of a bed of solid particles, it will move upwards through the empty spaces between the particles. At low gas velocities, the dragging of each particle by flowing air is low as gravitational force is more than the dragging force. Thus, at the low velocity, the bed remains fixed. No movement can take place. If we increase the velocity, dragging of particles by flowing air begins as dragging force now is somewhat greater but not more than gravitational forces. Now bed expands in volume as particles move away from one another, but particles will not move with the gas. With a further increase in velocity, it will reach a critical stage where dragging force is exactly equal to the gravitational force. At this stage, particles remain suspended within the fluid and are said to be fluidized. Now, the particles in the bed will exhibit fluid like behavior. If we further increase fluid velocity, particles conveyed upwards by the gas flow and go with air. After fluidization theory, let's discuss about construction of fluidized bed dryer. A typical fluidized bed dryer consists of metal tray with mesh or perforated base in which the bed of the material to be dried is kept. The mesh must be fine enough to prevent the product from falling through it when the dryer is not in operation. A gas distributor and an air heater are present in the dryer to pass the heated air from the bottom of the mesh. Just above the bed, tall columns are present which allow expansion of the bed due to fluidization. Airbags are attached to the air exhaust system to prevent exit of dust or fine particles. The height of the columns is made enough tall to allow for expansion of the bed due to fluidization and to prevent the removal of particles from the air exhaust system. The air exhaust system is connected to a dust recovery system and an exhaust fan. Now, let's discuss how this dryer works. Material to be dried is kept in the tray of associated mesh size. The tray is then connected to the dryer with nut and bolt adjustment. Then hot air is blown from the bottom of the bed, causing the material to suspend in air, that is fluidization. During fluidization, particles remain suspended and agitated vigorously in the column. The air performs two works as a fluidized medium and a drying medium too. Fine solids which may go along with the air may be collected from the exit air in a cyclone separator. I hope you understand the construction and working of fluidized bed dryer. Now let's discuss about advantages of fluidized bed dryer. First advantage is in fluidized bed dryer, heat transfer takes place very fast. Thus, the heating time required is less and hence it is useful for drying thermolabile material. Second advantage is it is an economical dryer. It has low maintenance cost as it has very fewer mechanical parts. Next advantage is it has high drying rates. Here, drying takes place 15 times faster than in other dryers. Another advantage is it leads to uniform drying. Here, drying of individual particles takes place rather than the entire bed. Hence, drying takes place uniformly. Next advantage is mechanical damage to particles is less. Another advantage is that in comparison with the output rate, it occupies a small floor space. So space needed to install it is less as compared with the output we get. Every equipment has its own advantages as well as disadvantages. Now let's discuss about disadvantages of fluidized bed dryer. First disadvantage is due to vigorous movement of particles in hot air, it may lead to production of electrical charges which may lead to sparking. Proper precaution should be taken to neutralize these electric charges and avoid sparking. Another disadvantage is due to turbulence of hot air, attrition of some materials takes place. It leads to production of fines. Now it's time to summarize the session. In this video, we discussed that final removal of liquid from solids by vaporization with the help of heat is called as drying. Then we discussed in granule manufacturing to reduce weight, to preserve crude drugs, to increase rate of size reduction and preparation of various materials, drying is important. Then we discussed that equipment used for drying process is called as dryer. We also discussed the classification of dryers by different ways with examples. Then we discussed that when a granular material is converted to dynamic fluid like state, it is called as fluidization. We also discussed the theory behind fluidization. Finally, we discussed construction, working, advantages, and disadvantages of fluidized bed dryer. I am very much thankful to you for watching this video patiently. If you think this video is useful, please like it and share it with your dear ones who will also get benefited from this video. If you still didn't subscribe to my channel, click on subscribe button and bell icon to get notifications of all my new videos. If you have any query, ask me in the comments or on my mail address. Thank you once again and see you soon in the next video. Till then, bye bye.